Okay, this lesson is going to be on right angles within geometric figures, which is section 7D in our textbook. So we have to remember that within geofigures, we can have right uh, angles. So here are some examples, like you can have an isosceles or an equilateral triangle. The hypotenuse, or excuse me, the height of those triangles can form a right angle with the base. And so then you can use right triangle trig to answer questions. And then the same would hold true on um, squares and rhombus, rectangles, kites, and you can see those images within that. In other types of geo images, we could have a tangent line. So your tangent line is the line that runs um, and intersects the point of contact of the circle here, and that can be or that will be a right angle with the radius of the circle. And you can have semicircles with the hypotenuse being the diameter, and then you can have a right angle there. Or you can have chords, and those chords end up forming a right angle with the using the radius and dropping the height from the center down to the chord. So let's take a look at some problems and um, answer them. So here we have an isosceles triangle because there are two tick marks identifying that. So what I can do is I can make a height of the triangle, and I can redraw this here. So this is x, this is my right angle, and this is 67. And I can use now trig. So if I want to find x, this is going to be 5 since that whole thing is 10. And so this is my adjacent side and my hypotenuse. So I can use cosine because I have this angle 67. So I have cosine of 67 is equal to my adjacent of 5 over my hypotenuse of x. And now I can cross multiply. So I have x times the cosine of 67 is equal to 5. And then I need to divide by the cosine of 67 on both sides. And I end up with x is equal to 12.8 centimeters if we round 3 sig fig. Okay, and then here would be another example, except now I am given the two sides and I am asked to find the angle alpha. So when I drop my height there, so half of 5.2 is 2.6. And then my hypotenuse I know is 8.3. And then this is my alpha. We just have to remember that when we solve that, that's only half of the alpha here. And so we will have to double our answer when we're done. So we have the opposite in the hypotenuse. So we have sine. So I have the sine of alpha is equal to 2.6 over 8.3. And then we have to do our inverse sine to get rid of the sine so that alpha is by itself. But if I do it there, I have to do it here. And when I do inverse sine, I get 18.3. But again, like I said, that's only half of this entire angle here. And so I have to take 18.3 and multiply it by 2, which gives me an angle of 36.5 degrees. Okay, let's take a look at another problem. So it says a rhombus has diagonals of length 10 centimeters and 6 centimeters. Find the smaller angle. So if you recall from here, we have a rhombus here. And so what it's talking about is like this side is 10 and this side is 6. Well, actually 5 and 3, it'll be half because we're only going to be doing half of it. So we go back over here, we can draw our rhombus. That's not a very good rhombus, but so if one of them's 10 and the other one is 6, that means the triangle that I end up forming is 3 here and 5 here. And it says find the smaller angle of the rhombus. Well, the smaller angle is going to be opposite of the smaller side, so that's the angle I'm looking for. And so that's going to be tangent since I have opposite and hypotenuse, or opposite and adjacent, excuse me. So I'm going to have the tangent of theta is equal to 3 over 5. And then we have to do the inverse tangent to get rid of tangent. And so when I do that, I